So we discussed about argument and modulus in previous class. So simple, what is like this is an argand plane. This is real axis. This is imaginary imaginary axis, and any point, and this particular plane is called as argand plane. Let's say there's any point. This is a complex number. Z is equals to x plus iota y. So the x and y are the coordinates. The point is P. The distance is known as the length. OP is what? What is the length OP? Modulus, right?
Yes, sir.
Modulus or magnitude of complex number. And what is the angle theta? What is the angle theta? Come on, you guys are sleeping in classes, right? It's okay, I understand. I also used to do that. But if you do this, you're not going to crack Andy. Okay. So theta is argument. Okay. The angle made by the real positive axis with the complex number in anti-clockwise direction. Okay. If we go and like in a clockwise direction, then we'll have to take the negative sign with theta. Okay. So let me revise to finding out the argument for this. First, we'll find alpha, which is tan inverse of modulus of y over x. And if the complex number lies in first quadrant, means that x is positive and y is positive. So the theta will be equals to alpha. If it is lying in the second axis, means x is negative and y is positive. So the theta will be equals to pi minus alpha. So now it is simple, like we'll just we'll put a negative sign, we'll write the same. We'll put a negative sign and we'll write the same. So this is for the fourth quadrant where x is positive and y is negative. Sorry, yeah, y is negative. Here both of them are negative, and here we already talked about. So done with the revision, and we have also talked about the properties of argument, which are very similar to the properties of logarithm. Any doubts, anyone? All clear?
Yes, sir.
So let's solve this question then, if it is clear. Everything is clear. Let Z1 and Z2 be two complex numbers such that the argument, okay. This is what? Conjugate, not argument. The sign of conjugate. So the conjugate of Z1 plus iota into Z2 is equals to 0. And argument of the product of those two complex numbers is equals to pi. So let's say uh, Z1 is x1 plus iota y1. This is first complex number. This second complex number. What is given to us is that Z1 conjugate plus iota Z2 conjugate is equals to 0. So let's take this term on the right hand side. Do you agree this will be written like this, right? So we have already discussed about this property, that if Z1 and Z2 are in product, and if we take the conjugate of both, then they can be written in this format, right? So, and as we know, what is the conjugate of a complex number is simply we have to change the sign of imaginary part of conjugate number. So using these two properties, we are going to solve the question. So now what we are going to do is that in first equation, we are going to take conjugate on both sides, taking conjugate on both sides. Okay. So if we take conjugate of conjugate, that simply becomes the complex number. If we take the conjugate, so let me write it only. So we are taking conjugate of the whole. So if we are taking conjugate of the whole, so conjugate of first multiplied by conjugate of second. So the conjugate twice will make it the complex number itself, right? Any doubts, anyone, about this point, that how have I written Z2? Clear?
Yes, sir.
Yeah. If we see iota as the complex number only, 0 plus iota, if it is the complex number, if we have to take its conjugate, so simply its imaginary part is becoming negative. So it will be written as 0 minus iota. Yes, right? Any doubts?
No, sir.
Okay. So if it is going to become minus of iota, so let's write it. Z1 becomes minus into iota's conjugate becomes minus of iota into Z2. Now minus minus cancel. Z1 is equals to iota into Z2. Great. Not what we have to find out, the argument of Z1 into Z2. Okay, let's discuss about this. Um, Argument of Z1 into Z2. Now we know it is a property simply like a logarithm. The angles will be added. Okay, this is equals to pi. Argument of Z1. Now Z1 can be written as this using the second equation. Iota into Z2 plus argument to Z2 pi. Now this can be written separatively because iota and Z2 are in product. Argument of iota plus argument of Z2 plus argument of Z2. That becomes twice. Great. So can यहाँ तक चीजें clear है? Is there any doubt till now? Any doubt?
No, sir.
Okay. So now I'm going to ask a simple question. What is argument of a complex number? Simply tell me, what is argument? Anyone can define? Anyone can teach? Anyone? What is the argument of a complex number?
Is it the angle, sir?
Yes. So if like this is the real number line, this is the imaginary. So angle between what?
Angle between real axis and the imaginary. Like, have to explain it.
Yeah, yeah. Uh, you're somewhat correct. So if there's like any complex number, and we have to join it with the line from the origin, and the with the line what angle it is making with the positive real axis, that is the argument. So now in this here we are not having any particular point on any argument plane randomly. Now we are given with, we have to find out the argument of iota, and the iota is simply here, 1 iota, and then 2 iota, and then 3 iota. Okay, so if iota is here, then let's say let's let's draw a line from the origin to iota. This is the line from the origin to the iota. Now what angle this line is making with the positive real axis? What is this angle? What is this angle?
It argue. Right angle.
Yep. So this is 90 degrees angle. So let me ask one more question. So it's not contextual to the question, but still minus of iota. Now what is this angle? This is in clockwise direction. What angle this is?
Minus
Minus.
the Mine. Okay.
Yep. Minus 90 degrees. So let's go back to the question. This was what? 90 degrees, right? 90 degrees. So pi becomes pi by 2. Now when we are writing pi means 180 degrees. Okay. Pi in radians is equals to 180 degrees. So whenever we write pi, it is in radians because we are not applying degree sign over there. 2 into argument of z2. Okay. Yes, everything is right. Yep. What we had to find out? Where is the question? Mm, hmm. We had to find out the argument of z1. Okay, will do fine. So if we subtract pi by pi minus 2, that becomes pi by 2 on the left hand side equals to 2 argument into z2. So let's take the so simply what we have solved till now is pi by 2 is equals to 2 into argument of z2. So the argue pi by 4, if we bring the 2 on the left hand side, that becomes the argument of z2. But we have to find out the argument of z1. Hmm. So let's use this equation. This um this given equation simple that kahan gayi? Here it is. Yeah. It was given as pi, right? Argument of z1 into z2 can be written in this form, and it was given as pi. This argument of z2 is pi by 4. So argument of z1 can be written as pi minus pi by 4, which is simply 3 pi by 4. Any doubts, anyone?
No, sir.
So its answer will be 3 pi by 4. See, what is the correct answer? Yes, it is the case. They have also done the same, but they have not explained why they have written this like this. Okay. So any doubts in the previous question?
No, sir.
Yep. So as we were discussing about amplitude, don't confuse argument and amplitude. Argument and amplitude are the same thing. Okay. And modulus and magnitude are the same. Anyways, so argument. So if we talk about the principal domain of argument or amplitude of complex number, okay? So it is minus pi to plus pi, where plus pi is included, minus pi is excluded, because minus pi and plus pi are the same angle, so one angle has to be excluded out of the domain. So this is principal. Wow, spelling of principal. So this is principal domain of complex number. Now, why principal domain? Because whenever we are going to refer to like finding out the argument of any complex number, then we will have to make sure that we are finding out in this regard only, from minus pi to plus pi, not anything more than pi. We cannot say the argument of anything is 3 pi by 4. Um, yeah, 3 pi by 4. Sorry, 3 pi by 2. Hmm. देखो, this is 0 degree, this is pi, this is 2 pi. Oh wow, nice. This is pi by 2, this is pi, and this is 3 pi by 2. Okay, this is 0 or this is 0 radian or 2 pi. Okay, so whenever we had to find out any complex numbers argument, so we'll go from here 2 here, but not ahead of the pi, because our principal domain does not allow us to go further. So if any complex number is lying below the real axis, then we'll go clockwise direction and we'll find out the argument. Okay, that's how this principal domain is defined. Clear? Any doubt, anyone?
No, sir.
So I want you to observe. Let me also once more write. Okay. To how to find out the argument, first we'll have to find out the alpha, which is tan inverse of modulus of y over x. And if the complex number is lying in the first quadrant, theta is going to be alpha. If it is in second quadrant, theta is equals to theta is equals to pi minus alpha. Simply minus of pi minus alpha, theta is equals to b minus alpha. I want you to observe for a minute. Done? Hello, hello. Anyone awake?
Yes, sir.
Yeah, someone. What about others? Guru, Rishi, Tanish, were awake. All slept. Are you really sleeping, guys? Anyways, enjoy. So, this was about the question. Now, coming to the so amplitude is equivalent and it is the same as of argument. So we have to find out the argument of the same. So first, what we'll do is we find alpha, so tan inverse of modulus of y over x. Now, if we compare this as x plus iota y, so y is minus of 1 here and x is root of 3. So if there is modulus, so it is simply 1 tan inverse of 1 over root 3. When is when is tan 1 by root 3? When is tan 1 by root 3? Anyone?
Um, 1 minute, sir. Is it 10:30?
Yeah. And what is the sign of x here?
What? Could you repeat, sir?
What is the sign of x y here?
Y is negative and X is positive. Yes.
Yes, x is positive and y is negative. So in which quadrant it is lying? The sign of x is written first.
Second quadrant.
Oh,
No, sorry. It's third quadrant.
holy Shalom.
No, sir. Fourth quadrant, sir.
No, I was not saying to you, saying to myself. I had written.
Oh,
You
okay.
see. Hmm. And mine is here. Okay. So plus plus. minus minus. In which quadrant?
Fourth quadrant, sir.
Yeah, fourth quadrant. So theta is equals to minus of alpha here. Alpha is pi by 6. So answer should be this. Clear? As easy as this. Okay. So let's move. This is the answer. So let's now discuss about polar form of complex number. If everything is clear about amplitude and the magnitude of complex number. Is that so? Polar form or circular form, we also know it like. So tell me, what is abscissa and ordinate?
Abscissa is x-axis, ordinate is y-axis.
Not particularly axis, but whenever we are like talking about any point, so the distance, the length of any point from the x-axis is the ordinate, and that the length between the y-axis and the point is abscissa. So this length is abscissa, and this length is ordinate. And naturally, the point will the x-axis x coordinate will act as abscissa, and coordinate will act as ordinate. So let's go and discuss about the right angle triangle that we are seeing here. So this is origin, this is OP. Let's say this point is M. So in triangle OPM, we can observe this angle is what? This is what? Argument,
Argument.
amplitude. Yep, yep. So uh, this is the argument. So now, what is length OP here? What is length OP here? If let me say,
Magnitude or modulus.
yep, yeah. So this is modulus, which is equals to OP. Let's write it as R. So R is the length here. So R is the hypotenuse here. X is the base. Y is the perpendicular. So according to this, what should X be equal to? Let's say if we find out sine theta, so that becomes Y over R, right? Is that so? Find out cos theta, that becomes base, which is X over R. So simply uh, X has become R cos theta and Y has become R sine theta. From this. Clear? Any doubts?
No, sir.
Yeah, I hope you guys are aware about the formula trick. Are you able to relate what is this?
So,
So tell me, what is cos theta here? Cos theta is base upon hypotenuse. Now tell me, what is tan theta here? Anyone?
perpendicular by base.
Yeah, this is the concept of this formula. So and how we can remember? How we can remember is like P stands for Pandit, B Badri, and then Prasad. Pandit Badri Prasad divided by Har Har Bhole. Pandit Badri Prasad upon Har Bhole. Clear? Any doubt? You can also use other acronyms. Uh, just you have to remember it. Clear? So let's replace x and y in the equation. So now the z will become x will become r cos theta plus iota into r sine theta. Let's take r common here. Rewritten as r cos theta plus iota sine theta. Any doubts, anyone?
No, sir.
Okay. There was another way to prove this. So now whatever this is, this particular form of complex number where r is magnitude and theta is the argument. So this particular representation in r, which is magnitude and amplitude, right? We have we are only having theta and r is the variables for the complex number here, not x and y. So this particular representation is known as polar form or circular form also, but most popularly as polar form of complex number. Clear?
Yes,
Any
sir.
doubts, anyone? Okay, so there is another way that we can prove. Let's divide on both sides by the magnitude, which is r. R is what? Basically square root of x square plus y square. Yeah, right. Do you agree? So if I write x square plus, okay, let's keep, we can also keep it same by writing that much. So if x is getting divided by r, it is simply what? It is the same. X, if x is getting, yeah, if x, so we can write it as x plus x divided by r to y divided by r. R is the hypotenuse here. X is what? X is the base. So base by hypotenuse becomes what? Cos theta, right? So this becomes z by r becomes cos theta plus there was iota. Yes. Y by r is what? Perpendicular upward hypotenuse, which is sine theta. So z becomes now the, which is written down here. Z becomes this. And further, the polar form. Clear? Any doubts, anyone? Any
No,
doubts
sir.
that how have I found it out polar form and circular form? Okay. If there is not any doubt, let's go ahead and discuss some questions of the polar form. So for finding out polar form, we just need two things. One is the magnitude and other one is the amplitude, the angle. So now the given complex number is iota raised to power 21 raised to power 3. We know when there is something like this, the power gets multiplied. So iota raised to power 63. Let's try to write this in the format of multiples of 4. So the nearest less multiple of 4 to 63 is 60. 60 plus 3. 60 is the multiple of 4, yes. 15 into 4 is 60. So iota raised to power 15 raised to power 4 or iota raised to power 4 is 1. So simply this becomes iota raised to power 3, that becomes minus of iota. Any doubts, anyone? Should I explain again? How have I opened the power? Any doubt?
No, sir.
Okay. So going ahead, now discussing about the complex number is minus of iota. Simply, so it is basically 0 of minus iota, right? 0 minus iota. So let's now find out the amplitude, which will simply become minus of 1. Why? because x is 0 here and minus of 1. Oh, not minus 1, plus 1. The length is always positive. Minus 1 whole square. So minus 1 whole square is square root of 1, which is 1. And the magnitude is always going to be positive because it is a length. Okay, not something else. So we are done with the r, finding out r, which is the magnitude. Now let's try to find out the amplitude. Okay, so this is a purely imaginary number, basically minus of iota. We have already discussed that purely imaginary numbers lie on this part of the axis, and the angle is minus of pi by 2. Clear? Any doubt, anyone?
No, sir.
Yeah. So the theta here is minus of pi by 2. So if we write it in the polar form, which was r into cos theta plus r into cos theta plus iota sine theta equals to r is what? Plus 1. Cos of minus pi by 2 plus sine of pi by 2. Okay. So our z is cos of minus pi by 2 plus iota into sine of minus pi by 2. Now we know now we know, I have also told this trick earlier in the classes, that after school to college, after school to college. Okay. So these are the coordinates 0, pi by 2, pi by 2, pi, 3 pi by 2. So all the angles between 0 and pi by 2, all trigonometric functions are positive. Only sine and its inverse trigonometric function is positive between pi by 2 and pi. And only tan and its inverse function, which is cot, are positive in the period of pi and 3 pi by 2. Only cos and its inverse function sec is positive in the period of 3 pi by 2 and 2 pi. Okay, because 2 pi is equivalent to 0. So now here if we see cos of minus pi by 2, so minus of pi by 2, for any angle to be negative, we have to go clockwise. So minus of pi by 2. Okay, we have come and clockwise direction to pi by 2. So somewhere here. So in this particular quadrant, cos is positive. This will be written as cos pi by 2. Simple. Iota into sine of minus pi by 2. Now here all the angles, all the trigonometric functions other than cos and sec will be negative. So there will be a negative sign, and this should be the answer. Cos pi by 2 minus of iota sine pi by 2, which is the first option. Clear? Any doubts, anyone?
No, sir.
Okay, let's move ahead then. This first is the correct answer. There are some things to note about polar form of complex number. So the form z is equals to r into cos theta plus iota sine theta is called the polar form or trigonometrical form or standard form or modulus amplitude form of z. All these are the same names of the same form, different names of the same form. So you have to remember all the names. So if any particular name is used in your exam, then you might relate what the what the examiner is asking from the examinee. So R is represented as the modulus of the complex number, and theta is as the amplitude or argument of complex number. The unique value of theta such that it lies between minus of pi by 2, minus of pi by 2 to plus of pi, where plus pi is included, minus pi is excluded, is the principal value of amplitude. The general value of the amplitude is 2n pi plus theta, means 2 and pi means here simply 0. Okay, where n is an integer, theta is the principal value of amplitude 0. So that's any bookish language. Okay, you know. While reducing a complex number to polar form, we always take the principal value. Okay, note this point. The angle has to be in this domain. Any doubts, anyone?
No, sir.
Any doubts? No doubts. Okay, then let's move ahead. Okay, now let's discuss about the Euler form of complex number. Euler जी की तस्वीर. Euler form of the complex number. Now we have already talked about the polar form, which is this. So it is simple that e raised power iota into theta is equals to cos of theta plus iota into sine of theta. Now, if we multiply the magnitude on both of the sides, magnitude is what? R. R on both of the sides, then it becomes this. So simply from first and second equation, we can conclude that z is equals to r e raised power iota theta, because this side and this side is equal. So this has to be equals to this. Clear? Any doubts?
No, sir.
So this is known as our Euler form of complex number. And there's one special thing about this is this cos theta plus iota sine theta is equals to 1 over cos theta minus of iota sine theta. And likewise, we can also say that cos theta minus iota sine theta is equal to cos theta plus iota sine theta. Clear?
Yes, sir.
Any doubts? No doubts. Great. So let's move ahead now. So now we have to find out the polar and Euler form of complex number of, let me write अच्छे से यार, find polar and Euler form of following complex numbers. So you are having two options. Everyone listen carefully. That one is the option that I will find out the polar and Euler form of the whole, and you'll have to find out the polar and Euler form of other questions. And the second choices, I will find out the polar and Euler form of other questions, which are more like typical, and you will have to find out the polar and Euler form of these numbers. But this is also very conceptual. However you will want, I'll give you the homework likely. Now, please tell what you want. Simply, in a polar and Euler form, we have to find out the magnitude and the amplitude. So if you are able to find out the magnitude and amplitude, job is done. Let me do it. Everything. Let me do everything. You just go and sit and relax. And I'll also write your NDA papers. No worries. Hmm. So talking about one. One is a real number, purely real number. Yeah. I'm not sitting parallelly to my laptop. That's why it is having this problem. Hmm. So there is no class after my class, right? Is there any?
No, sir.
Okay, so we can continue our class till the morning. That would be fine, right? Silence. Okay. So plus 1, where it will be lying here, plus 1. Minus 1 will be lying somewhat here. Plus of iota will be lying somewhat here. Minus of iota will be lying somewhat here. Okay. So we have to find out the magnitude and amplitude of all. So let's find out that first. So the magnitude of 1 is what? Someone tell me. What is the magnitude of 1? Anyone? Simple, yeah, it's very simple. Uh, z is equals to 0 plus, sorry, 1 plus 0 into iota, right? This is what the complex number looks like. We find out its argument. It's going to be 1 square plus 0 square, which is 1 itself. So the the magnitude is 1. Theta is what? What angle this particular line is making from with the positive real axis? 0, right?
0, sir.
Yeah. Now talking about minus 1, what is its magnitude? What is the length between origin and this?
-1 means 1.
Yeah, very good. 1. What is the angle?
0.
No,
No, sorry, 180.
positive real axis is this 180, which is
Uh,
pi. Yeah, let's talk about iota. What is this length? 1, 1.
1.
Yeah, how 1? Z is equals to 0 plus 1 iota. So the if we take its magnitude 0 square plus 1 square, simply 1. Now, what is the angle?
90.
Yes, 90. 90 is the angle. So this is 90-degree angle, pi by 2. So if we talk about minus iota, what is its length from the origin?
1.
Yes. What is the angle?
Um, is it -90?
Yes, very good. Minus 90. So simple. Now our job is done. Now we just have to write. So our polar form is basically r cos theta plus iota sin theta. Okay. Iota sin theta. So r is 1 into cos of 0 plus iota into sine 0. So this is the polar form. R is 1 cos of pi plus iota sine of pi. This 1 cos pi by 2 plus iota sine pi by 1 cos of minus pi by 2 plus iota into sine pi by 2 minus of pi by 2, sorry. So this is the polar form. Euler form is simply e raised power sorry, e raised to power, please respond laptop. It's responding somewhere else. Very good. So simply the objective is to find out the magnitude and the amplitude. If you are able to successfully do that, you'll be able to find out the polar and Euler form very easily of anything, any number. So now tell me, which set, like the set of all complex number is bigger, or the set of all real numbers is the bigger?
Set of complex numbers.
Yes. Yes, yes. Set of real number is a subset of set of complex number. Okay, so continuing our discussion, Euler form is r into e raised power iota into theta. Okay, so simple 1 into e raised power iota into 0 degree, 1 into iota raised power pi, 1 into iota raised power pi by 2, and 1 into e raised power iota into minus of pi by 2. Okay, so this is about finding out polar and Euler form. Absorb the slide once. Done. Now let's find out the Euler form of this. Simply two steps, magnitude and amplitude for finding out its. First of all, tell me what is x and y here.
X is -7 and Y is -7.
Yes, right. So the r is square root of 49 plus 49. That becomes uh, 98, which is 2 into 49. Square root of 49 is 7. 7 root 2 is the magnitude. Now let's try to find out the amplitude. So for doing that, first tan inverse O modulus of -7 upon -7, that becomes 1, which is pi by 4. Tan of 45 is 1, that's why. So now both of the signs are negative. So that happens in which quadrant?
Third quadrant.
Third quadrant. For third quadrant, we use this formula. So minus of pi plus alpha. Alpha is pi by 4. So that becomes minus 3 pi by 4. So this is the argument and this is the magnitude. So simply for Euler form, r into e raised power iota theta, r is 7 root 2 into e raised power iota into theta is what? Minus 3 pi by 4. 7 into root 2, 7 into root 2, e raised power iota into minus of 3 pi by 4. Minus sign is here. Third should be the correct answer. Any doubts, anyone?
No, sir.
Okay, let's move ahead then. Yes, 3 should be the correct answer. Okay, now let's discuss about De Moivre's theorem. So it's very easy. It simply says this. This is important and questions has been asked on this particular theorem. Listen to me carefully. So as it is, so simply it says that cos theta, and remember one thing, all the properties. Okay, I'll tell it later. So cos theta plus iota raised to a sine theta, if there is any power raised to this particular expression, then it can be rewritten as cos and the power into the theta plus iota sine of the power into the theta. Simple. So for example, if I say cos theta plus iota sine theta raised to power 2, so that will become cos of 2 theta plus iota sine of 2 theta. That's one example. Another example can be uh, cos theta plus iota sine theta raised to power minus of 1. Now this will become cos of minus theta plus iota of sine of minus theta. We know cos of minus theta is plus cos theta minus becomes sine of minus theta becomes minus of sine theta. So that's why this is this. So it can be written as cos theta plus of iota sine theta This also we have studied earlier, and this is important. You can memorize also. Clear? Any doubts?
Yes, sir, clear.
So this is one property of De Moivre's theorem. There is another, is that whenever like there is a case, if there is any complex number written in this format, cos of theta 1 plus iota sine theta 2 into cos of theta 2 plus iota of sine theta 2 into, and like this the product is going on and on and on and on till n terms, cos theta of n plus iota of sine theta n. So it can be rewritten as, the complex number can be rewritten as cos of the sum of all angles theta 1 theta 2 or whichever their terms were till the n plus iota sine of the sum of all angles whichever are there. Okay, till n terms. So this is another property. Any examples needed? So let's say cos of how should I, 0 degree plus iota into sine of, no, let me frame a question for you. Given arithmetic mean, let me change the ink. Given arithmetic mean of A, B, C, D, E is 5. Okay, and you have to find out cos of A, okay, cos A plus iota of sine of A into cos of B plus iota sine of B into cos of C plus iota into sine of C into cos of D plus iota of sine of D into cos of E plus iota sine of E. You have to find out the value of this. Okay, how will you do so? Any ideas, anyone?